This is Math 7, Section 1.3, Introducing Irrational Numbers. First, let's try to understand irrational numbers on the number line. Okay, here we go. Consider a small portion of the number line close to 0. If 1/4 is close to 0, then 1/8 is even closer to 0 than 1/4. Let's draw this. Here's 0. So if 1/4 is relatively close, alright, this is zoomed in, 1 would be all the way up here, then 1/8 is even closer. It's halfway in between. Then 1/16 is going to be 1/16 is going to be even closer, because we're multiplying times 2. Every time this number gets bigger, we get closer. If it was 1/32, it would be in the middle of here, and then 1/64 would be in the middle of here, and every time we get exponentially closer. So let's talk about what an irrational number actually is. An irrational number cannot be written as m over n. We're going to talk about how to find it on the number line here. So there's lots of holes. We have all these fractions, but there's holes in between them. And these are where the numbers that are irrational fit. One example might be the square root of 2. If you remember from this hands-on activity we did in class, we made this square. Square A was rational because you had the 2 on each side. But to find the side of square B, we found out that it was the square root of 2 was one of these sides after we folded all the papers in. So then coming to this ruler down here, we measured it, and you can see, let me zoom in, can't zoom in anymore, but look in your book, you can see that the square root of 2 is not completely on a line, but it's approximately on 1.45, almost 1.5, but a little bit less. And so what we had to do there to locate the square root of 2 on number line is approximate. Everyone double underline that. We are approximating by looking on the ruler. So all non-zero multiples of the square root of 2, such as 2 square root of 2, 3 square root of 2, 4 square root of 2, and of course our original here, just 1 times the square root of 2, assumed 1. Okay, these are all not rational numbers. They are irrational. And these you would also have to approximate to find it on the number line. Okay? Irrational numbers. Let's just make a note here also, make a star, that negative square root of 2 is different. It does not equal the square root of negative 2. This is actually an imaginary number, and we don't want to get there yet. We're just talking about irrational, not imaginary. Doesn't exist. Okay, irrational, that is where we're at. The negative sign is outside of the square root. It's not included. Let's do some examples of irrational numbers. Make sure you're writing all this down. Examples of rational numbers. Many square roots of positive integers are irrational numbers. If it is a prime number, and it is the square root of a prime number, it is an irrational number. But there are also others besides prime numbers. For example, 10. There is no square root of 10, therefore it is an irrational number. These are all examples of irrational numbers. Many cube roots are also irrational numbers. These are square roots. Many cube roots are, so the cube root of 2, the cube root of 9, remember 9 is a square root but not a cube root, the cube root of 11, and the cube root of 16, and so on. And the ratio of the circumference of a circle to its diameter, pi, and the golden ratio are also examples of irrational numbers. Let's make a little note. The golden ratio here is like if you draw a star, something commonly seen in math, the length of this line over the length of this line equals the golden ratio. You don't need to know that, just a little note. It's a ratio commonly used in science. Next part. Use area of squares to locate irrational numbers approximately. We are going to use the area of squares to locate irrational numbers approximately. That's the way we're going to do it. So you know how to find the square root of a perfect square. For example, square root of 4 is 2. These perfect squares enable you to estimate the location of an irrational number on the number line without even using a calculator. Consider square root of 2. When you square square root of 2, like let's square this, that equals square root of 2 times square root of 2, you get 2. You may regard the area of square B as 2 square units. So if this is the outside, and this right here is the square root of 2 units, well, the inside is going to be 2 units squared, because you're squaring this number to get square root of 2 times square root of 2, which equals 2. The units here, though, is squared, because you multiplied units times units, and we get 2 units squared. This is square B, the one that we've made. Note that 2 is more than 1, but less than 4. Both 1 and 4 are perfect squares, so we'll do it like this. 1 squared is less than 2 is less than 2 squared. So to find this on a number line to approximate it, we know it's between 1 squared and 2 squared. You read 1 squared is less than 2 is less than 2 squared, as 2 is between these two numbers on a number line. So if we draw a bigger square, square A, that is 2 units, inside it's 2 squared units squared, and this is square A. And then over here we have a smaller square, square C. Inside we have 1 unit squared. Outside here we have 1 unit. Then you can see that this square, the area is in between those two squares, square A and square C. Compare the side lengths. You get 1 squared is less than 2, square root of 2 is less than 2. Now, to approximate the location of square root of 2, consider another square D with the side length 1.5 units. The area of square D is 1.5 squared, which is 2.25 square units. So we can say 1 squared is less than 2 is less than 1.5 squared, because we know that 1.5 squared equals 2.25, 2.25 is greater than 2. So now we can approximate this square is smaller than square d with a side length of 1.5. Okay? Now, you can rewrite this as 1 is less than square root of 2 is less than 1.5, because we've taken the square root of each thing. So we could now approximate that the square root of 2 is between these two numbers on the number line. Let's draw that. 1, 2, 1.5. We've located the square root of 2 is between these two numbers somewhere. And we're going to put it right here. Square root of 2. It's only an approximation. If you get a calculator, you can get an even better approximation. You'll just get a non-terminating, a repeating decimal for that. Okay, let's do the next section that says use rational approximations to locate irrational numbers. Here we go. We've already located square root of 2 on the number line because it's between 1 and 2, and it's also between 1 and 1.5. Now that's about an approximation. We did that without a calculator. If you use a calculator and you put in, we're going to use a calculator, and you put in the square root of 2, you're going to get 1.41421356, and it'll keep going on the display. Now, the decimal shown is only an approximative value of square root of 2. Using this approximate value, we can identify the numbers to the nearest tenth that square root of 2 lies between. So we know that square root of 2 is bigger than 1.4, but it's also smaller than 1.5. And it gives us a little bit better approximation than we got up here. So now let's graph that. 1.4, 1.5, square root of 2. We put it a lot closer to 1.4 because you can see it's 1.41. It's closer to 1.4 here. It probably could have even been closer than I put it. Now use the approximate value of 2 to 2 decimal places is 1.41, and so that's how we put it closer here and how we found it on the number line. Now let's try an example. Write this down. Example 9. Graph square root of 15 on a number line using rational approximations. Because it's 15, it's a little bit less than 16, so it should be a little bit less than, square root of 15 should be a little less than the square root of 16, or 4. Okay, that's what we know before even doing it in the calculator. But put that in the calculator, and you get 3.872983346. So we know that it lies between 3.8. Okay, it's bigger than 3.8, but it's smaller than 3.9. So let's graph that on a number line. 3.8, 3.9. And it's going to be a little bit closer to 3.9 because there's 8.7 there. We can label this as the square root of 15 here. Okay, go ahead and try guided practice 1. Next, let's do example 10. We're going to graph negative square root of 3. Notice the negative is outside of the square root. If it was inside, it would be imaginary and it would not work. But outside, this is still an irrational number. So just guessing, we know that it's going to be between -1 and -2. Because 1 squared equals 1 and 2 squared equals 4. So we know that the square root of 3 must be and the square root of 3 squared equals 3. 3 goes in between 1 and 4, so we could also say, since 1 is less than 3 is less than 4, 1 is less than 3 is less than 4, put it in the same order, 1 squared is less than 3 squared, or no, is less than the square root of 3, sorry. So the square root of 3 is less than 2 squared. Okay? A little bit confusing sometimes, but let's put that in the calculator to find the negative square root of 3. And these are all negative numbers, by the way. Forgot to put that in. Equals negative 1.732058. Okay, we have this. Now let's graph that on the number line. 1.73. So we know 1.7, 1.8, it's between those, negative 1.7, negative 1.8. It's going to be, remember these are negative numbers, so it will be greater than 1.8 and less than 1.7, because negative 1.7 is over here, negative 1.8 is over here. It's going to be somewhere in between, a little bit closer to this. So we could say here is the negative square root of 3. Go ahead and try guided practice 2 and 3. And that is the rest of this video. We will see you in class.